To start out with, just by a show of hands, because I like to make people do things other than me, who actually has heard the term serverless with regards to architecture? Good, most of you. Who's done anything that they'd consider to be serverless? All right, and of those hands, who's done serious things like it actually saw the light of day as a production app? Awesome, we have a few, great. So you are in a very small select company right now, as you probably are aware of. So I'm not going to give a definition because most of you people knew it, or at least had heard of it, but we will get to it because I'm going to start building up to it. Just to quickly go over the objectives of this talk. I will actually say what it means, but as I said, we're building to it. As you can probably tell by the branding, I'm predominantly in AWS. It's what my organization has chosen, and like according to all the Gartner reports and that sort of thing, it is kind of the leading cloud provider. What I'll talk about, the concepts are cross-cloud. They will be even if you're building your own. But many of the specifics will be targeted toward AWS. The key differentiator, I would say, to this talk versus just one on serverless is I'm going to be talking about what we've done, what services we've used, why, what we've run into, et cetera. Because we have multiple consumer-facing production applications written in this style. And along the way, we've learned quite a lot. And yeah, that kind of hit that one too. So who am I? I'm a technical back-end lead for Stanley Black & Decker. You've probably heard of them. They make a lot of tools. They also do other odds and ends. Stanley is like the leading provider of automated doors. So anytime you walk into a door that opened for you, if you look in the corner, it probably has a Stanley logo on it. I've had 7 years of development experience. In this room, that's a very small amount. But jumping to the last one, we've been doing serverless deployments since September. Not many people can claim that because that was around the time the term was coined. I've touched a number of different languages. The fun one there, the one that I love, is Erlang. The one I actually have to do stuff in is Node. Part of that is because we're in AWS, we're using the serverless style, and Node is a first-class citizen. Java is too, Python is as well. You can run other languages, but it would not make sense for us to spin up an Erlang VM. A lot of what I've done has been distributed systems with a focus on them being fault-tolerant. I will mention a few different places where AWS is, in fact, lacking for me being able to see the internals of what's going on and how things break and that sort of thing. So what exactly is serverless? This is the build-up. Some of the people in this room recall when you're writing an application, you had to provision servers. You had to actually write down what your requirements were and hand them off to IT, have them take 2 months to order the hardware and get it set up for you, and say, OK, here's a server, and heaven help you if that server in any way failed to meet your criteria, or you found out your requirements changed, or something broke. And that was what it was until, obviously, we started getting virtualized hardware. Everybody loved this. We got to push on to IT. OK, you guys go deal with the servers. I just want to specify what my requirements are, and you can give it to me within a day or two, because you could actually give it to me within the hour, but we know how fast IT works. But we had to start caring. Our company had to care about the VMs. That was usually fell on the application developers, but maybe you had like an ops team that had to worry about that. And then there was IT people who really cared about those bare metal servers and making sure they were healthy, and had to deal with the hypervisor as well. Like, these were all things that our company had to deal with, even if that wasn't really where we derived value. And so that's where the cloud began to come in, right? The cloud said, look, we'll handle the bare metal servers, we'll handle the hypervisor, we're just going to give you a VM. And you can treat that as your server, but I think actually the keynote yesterday, just that experience of being able to make an API call and suddenly you have 20 servers. Like, that's really powerful and really cool. And that was the big promise of the cloud. But then as to start differentiating themselves, because lots of people jumped on this bandwagon, they started offering hosted services. So, and other people were offering it sort of separately, but the cloud providers started biting into that really hard. So you have your VM to worry about, and then built on VMs that you don't really see are a database service. In Amazon, that's RDS, right? File storage service, whatever sort of thing that you could easily abstract out. And then you didn't have to worry about the VM. You could just as easily go say, hey, go provision me a database, or go, create a folder to throw some files in, or whatever. We've heard lots of talks about containers. I'm not going to go too in detail with that, but that gave us another lovely level of abstraction to where we could start, bundling in all the bits we needed to just throw onto a VM. We still have to care a little bit about the VM, hence why I've left it kind of bright, but not as much as if that was where our application was running. Then it's more just like securing it and making sure that it's a good environment for our container or containers to run on. Sort of simultaneously, we've had platforms as a service, where some other company was saying, you know what, we're going to give you this nice little playground built on top of VMs, where you can just sort of build your app and not worry about the particulars of this, and you can kind of scale it fairly easily. Heroku's a name I'm actually familiar with. Spin up some dynos, and yay, we've got our application running. You may have a database baked into the platform, or you may use a hosted service, just depending on the particular platform you picked and that sort of thing. Also a useful level of abstraction, but that kind of brings me to, well, serverless, where rather than having a platform, we just have functions. Now this is kind of a lie. There's more behind there. There's more you can introspect in, but fundamentally the goal is to make it so that all you care about is this little bit of code that's running. From a function, you can call a database. From a function, you can call to S3. But what you should care about is just, here is my code. Here's, tying into sort of the FP, there's a functional programming talk. We should care about what's going in, we should care about what's going out, and we should care about side effects. And we shouldn't really care about a whole lot of the other sort of surrounding infrastructure that went into it from an architectural level. The developer should from an implementation level, but that's all that they should have to care about. And so we've, this is kind of this new-ish abstraction that was sort of has begun to see some actual play. And what serverless then is the marriage of those functions as a service with other backend pieces, backend as a service. So you have a function that's going to contain your logic, and then it's piecing together all of these backend pieces to create some useful bit of sort of system level functionality, or ideally your entire application. Kind of digging into what makes up function as a service. Well, obviously it should be a user-defined function, and these are running inside a container. You don't have, ideally, don't have access or should not have access to the specifics of that container, because you shouldn't care about the specifics of that container. That should be handled by the vendor. Again, the whole idea is to abstract this out just to the bits you do care about, which is your code. Because they're being spun up as individual functions, the functions should not necessarily be able to interact with one another. One of them failing should in no way affect another one. And they generally achieve this by each one gets its own container space. So they're shared nothing, which for those of you who have built distributed systems is a really nice property to have. It's also a tricky one to deal with. But it means that you can have 100 functions, 1,000 functions all running concurrently. It doesn't matter because they don't interact. There's no shared state between them. Now, we'll get to that, of course, because we need state. But for the purposes of the function, that's a very nice property to have, and it makes it very easy to deal with. They can be spun up on demand. Because it's just launching this very set thing with code that's then going to be called, like there's nothing special about it, and it can be frozen away as like a VM image that can be booted up very quickly. Or even have one running just kind of in the background and ready to just be called. So as your need scales up, they can scale up. And as your need kind of stops, they can just be quietly spun back down. Because of that, it'll scale very, very easily. Make 1,000 calls, get 1,000 containers. If you drop down to maybe 20 containers per second, well, then you're going to have your 980 just spin down, and those 20 will sit there serving up requests. And as I mentioned here, these functions need to have some integration points with your cloud environment. And there are some open source solutions for this if you're building your own on-house cloud. But some way to actually call these things in a sane manner, and we'll kind of dig into that. As I mentioned, though, these containers do have startup latency. I'll be digging more into that too. but it's something to bear in mind. If your use cases, your business domain is this super low latency, needs to be real time sort of thing, this solution's not for you. And I'll be digging more toward the end of when is this solution good, when is this solution bad. Go ahead. So it depends on the cloud provider. For AWS, whenever it gets a call, if there's an existing container, it'll use it. If there's not, that's not currently processing a request. If there's not, it'll spin one up. If there's no request going on and the container's just sitting there, it's undefined. People have measured anywhere from about 5 minutes up to a couple hours. It's just as Amazon needs to reclaim it. So yeah, it's no. In general, you shouldn't have to care about that. That's kind of the goal, is that whenever you need one will be spun up, with some caveats. And, sorry, was there?
Yeah, at least in recent conversations with Amazon, the answer is when you spin up a container, a Lambda container, for example, it's on a VM that's dedicated to your account. So you're a shared hypervisor, but you're not time slicing Lambda instances with other customers on the same host currently.
Well, that's an interesting answer, because what I've also seen that's really interesting is, and I was going to get to this a little later, but it's very relevant now. When you specify your Lambda, you specify a level of hardware you want to dedicate to it. So I want to run it with 128 megs up to 1.5 something gigs of RAM, and that also scales the minimal amount of CPU. And I say minimal because sometimes you will see it processing much higher than that. Why is that? I don't know. But it seems like, oh, well, the system, whatever pool it's pulling from is, that VM is less in demand. And it may just be how it slices. If it is indeed in your own account, it may just be how it slices containers across VMs. But I know some people, for a contractor in the space that ran some load tests and found that even on their minimal settings, they would occasionally see the processing performance matching that of even the ones with the highest settings for very brief periods, as though it had the whole VM to itself. So.
One quick question before you go on, sorry.
Sure.
Just to make sure I understand, is this the same thing as a Heroku instance, or is that a different type of application?
So Heroku is a platform as a service. You're not bundling your application together. You are literally just saying, here's a function. Here's any libraries it needs. I'll show you an example in a little bit in AWS, but it's effectively a single function handler that will then call and execute your code. There's no other understanding of that function of any other infrastructure or anything a platform guarantees you. It's just whatever you bundle together is what's going to be run. And just here's some examples. AWS Lambda is kind of the biggest one in the space, because AWS is kind of, again, sort of the largest provider of this, just as a cloud provider. Google has one called Cloud Functions. Azure has functions. Kind of see a trend here. IBM has OpenWhisk, which is part of their just open platform that you can just go and download and play with. But of course, they do have a hosted service offering that you can go sign up with them. I'm not sure what what's compelling about that, but if you're an IBM shop, that exists too. Or if you have a mandate that everything you're running has to be open source, you can build your own functions as a service sort of environment that your developers can then run functions in. There's a few others. There's some people doing sort of on their own open source style things. You can find them on GitHub. I don't think they're as notable, just because since they're one or two people deciding they're going to do this, I don't know that I want to run a production workload on that. But it's kind of cool that people are taking on that task. This is what it looks like pertaining to your question in AWS. This is sort of a default, where when a function gets called, it'll have some sort of event passed into it. It's whatever's triggering the function. Whatever calls it will pass in some sort of blob. In this case, it's JSON, though they did add some binary handling recently, which I haven't dug into too deeply. There's a context, which is, well, when this function got called, the context of it being called, was there a user associated with it? What service did it? It includes some nice things like, what's the maximum execution time that this function can run? Because they all have a timeout. So you can find that out. You can find out how long it's been going, too. So you can always check, how long do I have if you're going to do some sort of expensive operation to decide whether you should do it or not. And then a callback, because this is Node, you say, I'm done by calling the callback. And with that, you can also pass like an error or similar. So there you're just seeing, like, I'm printing out the event, the context, and done, which is actually really, really useful, just because it's hard to debug the actual, like, in the cloud, this is what's running thing. So when you're developing, I frequently find that I'm doing this because what does that look like? Amazon gives you some examples from when it's integrated with different services, like what does the event look like? But I always like to just see it and be like, oh, that's what it is. So yeah, some specifics to AWS Lambda. If these are meaningful because you're using or have considered using AWS, have a look. If you're not, it's less useful, but the other cloud providers are similar. As I called out, RAM and CPU are minimums. It can actually go higher in the case of CPU. It can take a little bit to start, but containers do get reused. Note that one, there is an invisible limit on containers per account. It's not actually invisible, it's just not called out like super like, there's 100 or whatever that you can use. But just a service ticket will increase the limit. The idea there being that you shouldn't be able to just accidentally spin up 1 million calls because something ran out of control. But as your production workload goes up, you may need to occasionally put in a support ticket to increase the number that can run concurrently. And that is concurrently, because as I said, any container that's already spun up will be used again. Logging per whatever language you're using, those logs automatically go into Cloudwatch. So across all your containers. And that makes it a little bit difficult to really follow them because it's per container. So if you have 2 containers, they're logging kind of independently. So you don't get an overview of time across the whole system. You get an overview of time per container. I'll get more into that later, but it's one interesting little caveat. You do have access to the underlying OS. You can shell out to call system commands. It's running on the default Amazon Linux image in the case of AWS. But that way, if you need to make some OS calls, you can. You also have a bit of scratch hard disk space. I'll get into the caveats of that, but you can probably guess your containers are both reused and scale out. They automatically get an IAM role. If you're familiar with AWS, you know what that is. If not, don't worry, I'll be getting into it. And then your billing is just a combination of how long they ran versus how much, or times how much hardware you dedicated to them. So as I alluded to earlier, a bit of code that you can run but can't actually trigger in any way is useless. They do respond to events, and your cloud provider has to hook them up to certain events, be able to have those set integration points. I call these out separately because as we like to think of events, there's at least to my mind, there's 2 different kinds. There's one that is externally caused, i.e. something's triggering this thing to execute. But there's also one that's less external, depending on how you think of it, but time, right? How you choose to think of that, I don't know, but in my mind, time is its own special beast. So you can have scheduled events set up in Cloudwatch to trigger lambdas based on that you can actually put in a direct cron-related string. So if you have existing cron jobs that are, you've got an EC2 instance spun up just to run those, this is a real easy win. Just to call that out, here's where you can, in the Lambda configuration, there's a little button. You go over to triggers, add a trigger. And then it'll give you a list of all the integration points that they have. And for scheduled events, it's kind of hard to see here, but I just wanted to give you an idea. It's in CloudWatch under rules, event rules, and then as you see there, you can just put a cron string in there or define every 5 minutes or whatever. And I want to pause on this slide. Most of you raised your hand, so this isn't going to come as a surprise, but this is sort of the key enabler for going serverless. You can have REST calls trigger lambdas. It supports HTTP termination. I know there were talks on using gproc, and there are other, obviously there are alternatives to REST, but it is sort of the language of the web. It is extremely general, and most solutions can kind of get by with it, even if not ideally. So it's what they support currently. And It means that you can have a RESTful interface that will then immediately call into some Lambdas, execute some stuff, and return. And this is sort of, this feature was what got people thinking about going serverless, because a lot of the times, as you saw from some of those earlier slides, we've pushed a lot of backend stuff into these hosted services. And we still have an application left. And what's that application doing? Well, a key component is handling our APIs. It's doing some other stuff frequently. We frequently have some state manipulation or storage, caching, et cetera. But a lot of the times, if we are leaving that in the application, we either are not scaling out. We have one monolith that we're hoping handles all our traffic, or we have built sort of a distributed layer in the application to try and handle, what happens when this value updates. How do we let everyone else know about it? How do we, do we maintain consistency, et cetera? Or we're pushing that out to some other piece of software to handle that for us. Maybe we have Zookeeper or something like that. If we're already pushing it out, which is the right answer with any sort of distributed system, what's left is just handling the API. So what's left is replaceable with serverless. And then because we love, diagrams, lines, and boxes, clients connect to Amazon API Gateway via HTTP. There's an integrated mapping with the Amazon Lambda. From there, you can just make SDK calls to other AWS services. And then the Lambda returns. Based on that, you get an HTTP code. And it's fully REST compliant, whatever that means. You can do post, pushes. Yeah, I mean, it's poorly defined, but you have the full set of HTTP verbs and status codes and that sort of thing. And as an interesting aside, you can invoke Lambdas from other Lambdas without going through the API gateway. You have to set up the permissions for this. And there's an obvious caveat, which is timeouts will stack. That is, if I have one thing that has a timeout of 3 seconds that's calling something with a timeout of 6 seconds, and that one that's that's being called that has a timeout of 6 seconds, well, runs its full 6 seconds, the one that called it's going to time out. But you can do some powerful things with this. You can have some interesting ways of recombining Lambdas into sort of this separation of concerns. It's not always the right solution. In fact, I would argue most of the times it's not, but it's a useful tool to be aware of. And then, yeah, there are ways of linking Lambdas up using simple workflow, is what AWS calls it, and then Lambda step functions. There's some severe limitations with those currently. I don't really use them. I played with them. But one of the key issues is that, Lambda step functions is one Lambda that's you're then configuring to call another Lambda, or array of Lambdas whose then answer or responses will go into another Lambda. You can create a whole sort of workflow with just Lambdas. The problem is that you can't have a dynamic number of Lambdas spun up. I.e., you can't have the output of one Lambda be an array and spin up a new Lambda to process each item in that array. It's been lodged as a feature request, but right now that lack means we're not even evaluating it as anything useful to us. Which brings me, as I said, I'm used to building fault-tolerant systems. So one of the sort of key questions I had when first being introduced to this is, what happens when my Lambdas fail? Because my code ain't perfect. And I want to caveat this, specifically the Lambdas. What happens when the cloud provider services fail? This is one of the problems with being in the cloud, right? Like, it's very difficult to nail down exactly what's going to happen in the event of failure. Because I can't trigger a failure. I can't go in and say, hey, RDS, introduce a partition between the master node and one of my replicating nodes, because I want to see what happens. Well, I would love, and I've also put this into, because we speak directly with AWS TAMs some of the time, and I've said I would love like a test environment in AWS where I can basically introduce a chaos monkey to start messing up AWS infrastructure, because I want to know what happens. But what I can tell you is when Lambdas go wrong, they behave differently depending on how they're being executed. And there's 3 different cases, as I call out here. If they're being called synchronously, and the key example of this is, well, your HTTP calls through the API gateway, it'll return an error. You'll get if you're doing that, you'll get a 500. Just what you'd expect. So that's not surprising. Asynchronous, it does the right thing in that it retries. AWS's guidelines for anytime something fails is retry it, which oftentimes is the right answer. Not always, but in this case, it'll set it up multiple times, and then you can just configure it to send that event to a dead letter queue to process later if you want. or just to be notified about it. I've got things just emailing me, so I go, oh, that failed, okay. And then streaming services will be retried in order until success or expiration. And this is something to be aware of if you use streaming services. There are two of them. One is DynamoDB. If you hook up a Lambda to execute based on a DynamoDB stream, i.e. every time something goes into your Dynamo table, execute this Lambda, that's a stream. And then Kinesis, which is their streaming service. Throw in events, and then it will funnel them into Lambdas. Generally, you set some number of worker Lambdas for a Kinesis stream, but if something starts failing, it can basically tie up one of those workers until it expires or otherwise succeeds. So just be aware of that. Kind of, a really interesting caveat. Yeah. Which, I mean, if you're building a distributed system, you want that. You really, really want that. So here's kind of a summary slide, just as a useful, summarization. I like them periodically, just as kind of like a recap and be like, okay, yeah, I haven't missed any key points, but I'm not going to sit on it. So that's functions as a service. As I said, there's kind of two parts to this, and this is where I'm really going to start getting deep into this. If you're more interested in sort of like actually building REST APIs and such, like as I mentioned in the intro this morning, there is a session at 1 where David Acteri is going to be doing a demo of building one of these with full stack, front-end integration and such, which I would highly encourage you to look at if this is something that interests you at all. So backend as a service. And this is where it starts getting really AWS heavy, because this is kind of my wheelhouse. This is where I have the most knowledge. Again, some concepts will expand outside of AWS. So to your point, state. Just as with functional programming, we can talk about making immutable state and pure functions and things like that, but pure immutable state isn't useful. We have to in some way describe mutable state, and there's some neat hacks in functional programming languages I'm not going to get into, but if you've ever looked at Haskell and you've seen the way they bend over backwards to do that, it's both cool and frightening. But in this world, in a serverless world, persisting state means distributed state. It has to be, because, well, you have all these functions and they don't talk to each other. There's no single point of like my application where I can just throw things in memory and know that I can go read them out later. So I have to distribute it, or I have to persist it into something distributed by its very nature, because there's nothing bundled in with my function. And that introduces some caveats. Per, again, the keynote yesterday, it's the problem you have with microservices, right? Like, your state ends up being separate from the code, which is a really useful property for distributed systems, but it makes it more complex. So I want to just talk briefly about S3. S3 is like my go-to tool. If you're building a serverless application and you can possibly in any way shape your data to fit into S3 as files, you want to do it. It's completely backwards to what we're used to. We're like, no, we need to put it into a relational database to impose this ordering on it because reasons. You should never use a flat file, which effectively is what S3 is. But S3, like, your creates are strongly consistent, your updates are eventually consistent, it generally just works, it's super cheap, and it scales. Like, Amazon's going to handle the scaling for you. There's nothing you have to do. So you're running one function every 5 minutes to 1 million functions per second, and they're all writing and reading from S3, it'll handle it. It'll scale to that. And that's absolutely wonderful, because it means you have nothing to do. As an architect, this is, scaling is one of your key considerations. How do we make sure we do that? S3 is how you can do that. It's also one of the few services Amazon has that actually has an SLA. Whether they deliver on it's anyone's guess, but they do provide one, and they do provide credits if there's downtime. Yeah, I mean, well, and to be fair, they do also say, go multi-region. S3 is also pretty easy to go multi-region. I mentioned it can also trigger off updates, because as we'll see, there are some services that you will want to use that don't. So anytime you drop something into S3, you can trigger another Lambda to process it, which is, again, very useful, because it means that in my sort of user-facing thing, I can have a request come in, throw it into S3, respond, OK, and then it goes and does the heavy processing. It doesn't actually hold open the user connection. It's version controlled if you need it. But obviously, like the fact that it is eventually consistent can lead to some interesting stuff if you don't take that into account. Again, you may have been in talks earlier that were basically eventually consistent has some bugaboos, right? And it's file system-like, so you can't just query across it. And they actually have some tooling with it. I think they call it Athena, to basically go and do analysis on your S3 stuff. But in terms of your application, just being able to do a join, there's no join, right? There's go read the file. So you have to design your data structure to, I can go read the file or the files and figure out the best way to do that. Another obvious contender is Dynamo. It's also infinitely scalable. It's queryable to a degree. You do have to optimize your data structures for reads, and sometimes, if you've done any sort of NoSQL database, you already know that you need to denormalize, copy duplicates of your data based on what kind of queries you want, etc. But I mean, it generally does work. It is fairly expensive, and you have to control throughput. There are, as you'll see, like you can have serverless implementations, and there's people have written things to do this that will basically be checking through Cloudwatch how much you're using your Dynamo. See, oh, you've crossed the threshold. I should probably up your throughput for you. Or, oh, you've dropped below threshold. I should probably drop it down, which is cool. However, there's caveats, because Dynamo limits, basically, Dynamo has some guarantees about when it's going to start sharding under the covers. You don't see this. But there's a certain amount of throughput, a certain amount of storage. I know it's like 10 gigs of storage, and I think it's 1,000 writes or 2,000 reads, something like that, per shard. And as your throughput increases, it'll up the number of shards, because that's the maximum. So if you have, you're needing to store 30 gigs or 3,000 reads, or 3,000 writes rather, it'll make it into 3 shards. But then if you drop it back down to, you had a throughput of 30,000, now you're dropping it down to 10,000. Well, that 10,000 is going to be split evenly across your shards. It's not going to allow you to do 10,000 reads per second from one of those shards. So it's just an interesting caveat to be aware of. It can bite you if you're dropping throughput down a lot. So if you have very variable access patterns, this might not be the right thing to do. But if it's slightly variable, or maybe you have a one day where it doubles or that sort of thing, this may work just fine. And then what we're all familiar with, relational databases, which there's a hosted service for RDS. We know this. It's familiar. It's everyone in this room, I would imagine, has used a relational database, knows how to design data and systems to take advantage of it. This is, this is in everybody's wheelhouse. There's nothing new about it. But there's a reason people came up with NoSQL in the first place. Now, that said, there's a lot of knowledge in how to scale a relational database. Like we have 30, 40 years of how do we scale these things up. So I'm not saying you can't do it, but there is a limit. Like there's you can only scale vertically. You can't scale out horizontally without sharding, which you can then do, but it means you have to start taking on those concerns. I say a questionable distribution story because of that, and because fundamentally, again, what happens in the event of a partition? Yeah, it'll fail over, but what if it's a network partition? I can still talk to both ends, and just fun things like that. That's what I'm saying, is RDS. RDS is Amazon's. Yeah, there are others, sure. Yeah, and you are free to use them. However, be aware that there is a data cost with all the cloud providers with data going out of their cloud. So if you are relying on a database as a service that is hosted in some other cloud, or some other competitor, basically, you're going to be charged twice, basically, because you're being charged for the data going out, as well as whatever the, in Amazon, these should be in a VPC, just because you don't want them open to the world. You can run Lambdas inside of a VPC. I'll touch on that. Because it is a database, there's settings you have to control. You have to actually go in and modify things and tweak it, and that gives you a lot of power, but it means that there's more oversight required of, you or the developers or the DBAs or whoever's in charge of that. And then there's some complexity when it comes to connection handling. Because if you'd imagine, let's say I have a database that has 1,000 connections. What happens if I set my Lambda concurrency limit to 2,000? Well, I've got 2,000 containers and only half of them can get a connection. I mean, that's kind of problematic. Now you can retry, as I said, Amazon's like canonical response is to retry, but you're going to have to handle that. You're going to have to understand you're going to very frequently get, responses indicating your database does not have any open connections. So generally speaking, you probably want to have the number of Lambdas matching the number of connections. There's also something called an ENI, which is an elastic network interface. If you're running inside of a VPC, these are basically how many interfaces they have to allocate to VMs spinning up inside of your VPC, inside of your subnet. And this is where I know, like, at this point, the Lambdas are inside of your pool because it's, in your VPC on a specific subnet. But because of that, like, there's a soft limit of like 350, I think, for those that you'll need to request to be upped as well. So here's kind of where I touch on a fun little caveat. Your containers do have memory. Your containers do have hard disk. You can use them. You can store things outside of your function handler. Like that node function handler, if I put something in sort of the module level namespace, or in Java land, if I have, my entry method inside of the containing object, I can store things there. And that will persist as long as the container persists. But that's not the only container running. Like, there's other containers. They won't have any access to that data. This can be a useful little like first level cache. Like if you're having to retrieve something that's expensive and not updating very often, that might be useful. But do be aware of some of the caveats with it. In fact, just as a fun little story, we had a junior dev who took advantage of that to load up. I think he was just reading something from the file system that we had bundled in with the code. And he was storing it in memory. And as part of his process for reading data out of it, it was like a JSON object. So, he was performing an operation that changed the data structure. It was, I'm blanking on the term, destructive. Slicing or popping something off an array or that sort of thing, so that the underlying thing's sort of memory changed. And it led to a really fun behavior where we went to call our API where the first response came back fine. And then we call it again because we're just doing it manually. The second response seemed to come back fine, but we're just eyeballing it. And the third response returned back an empty object. And he spent like an hour banging his head to try and figure that out. So storing things in memory or persisting things on disk, like, treat them as immutable if you're going to do it. Just be very careful of that. So all of that said, hopefully, if you've heard the term serverless, but even if you haven't, like, you're seeing how, okay, I could start building some CRUD-like, functionality and with a REST API fronting it. And honestly, that's probably like 50% of our business cases. You may be doing something super exciting, but I know for many things I've done, at least, even if it was a super exciting project, there was still like 50% of it that was still just like, okay, we got to write an interface into it. And then half of the things that interface is doing is just reading some data out or updating some data and returning. So this gives us a way to do it, but we'd like to do some other things. Yeah?
So I was wondering about the API gateway in the Lambda functions. How do you write auth middleware?
Okay.
So can you talk about anything with your experience with that?
So I'm actually going to get more into that. There's a sort of a canonical way of doing it in AWS. However, if you don't want to use that, the API gateway does give you a way to specify a custom authorizer that will be called prior to your code. I know we ran into an issue trying to do that. What we ended up doing, and I'll get into this too, is you can write your functions as libraries, and they should be. So you can have essentially a separate authorization middleware that's going to be loaded in and called, just loaded as a library in your function handler, and then call it just to validate, okay, this person has access or not. So you have it both at the code level, and AWS does provide a separation at sort of the infrastructure level if you want to do it that way too. In terms of third-party things, we're using auth0 or we're using some other thing, then you're probably going to have to include a library to, or you're probably going to have to use one of those to actually validate like a token or something that's being sent in. So this is useful. It's not everything. We already talked about triggering events, right? We could, that's a way to deal with things outside of the user request response model, right? So as I said, throw something in S3 and trigger Lambda, on top of that. But there are some useful things we've played around with and found help us create reasonably detached architecture so that things aren't just deeply coupled. And everybody in here is probably either done, been told to, had it suggested, or joked about. We need to decouple it. Throw in a queue. There's a distributed queue. Per that, it's a distributed queue. To maintain the capabilities of being distributed and to be scaling almost infinitely, there's no guarantee of message order. But that's okay, because your messages should probably be idempotent. If you've dealt with any sort of queuing system, and you haven't done idempotent messages, you've probably seen weirdness. If you've dealt with a distributed queue and you've ever tried to, play with it, test it really good and hard, you've definitely seen some weirdness. Otherwise, you weren't testing it hard enough. They do have FIFO queues in 2 regions right now, extremely limited. They also only scale to about, I think, 1,000 messages on the queue per second. That's the max, because they're essentially under the covers using Raft or Paxos or something to maintain consistency. They also maintain a history of messages that have been seen over the past 5 minutes, which will allow them to deduplicate messages. That's great, and they claim, exactly once delivery, but you probably know exactly once is a myth. And as I said, it's only over 5 minutes. You get some really degraded network conditions, some really aggressive retrials, you can still see the same message again. But it's there. Kinesis, I mentioned it earlier. This is for stream processing. This is actually pretty cool because you can have a whole bunch of, say, analytics data being dropped onto this Kinesis stream, either from a Lambda, or if you wanted to, you could give clients access directly to the stream. And it's just, you do have a little work with it, which I'll touch on. But basically, you can then say, I want to drop these off in batches into my Lambda. Or I want to directly pipe it to S3, because that's effectively where I want it to go anyway. You do have to provision shards, which are a certain amount of throughput. But it gets hefty. And then, as I said, if you've got lots and lots of really small messages, that it would just be prohibitively expensive to call Lambda for each and every one. Drop it onto Kinesis stream and then throw 1,000 at a time into a Lambda. So that's a few options to process outside of the request response. But if you're doing work outside of the request response, how do you inform users? Well, if you're thinking about it, for especially a mobile client, if you're executing Lambdas anyway, you can just use the SDK for whatever use the Apple push notification service, right? Push them a notification. But Amazon does have a few options, and again, the various cloud providers do have other options because not everything's a mobile client. They've got some easy options for sending emails. They've got some easy options for sending SMS messages. They also have an option for just triggering a subscribable pub sub for HTTP messages. SNS is effectively their pub sub mechanism. I want to call attention to the third one because the AWS IoT service is obviously intended for IoT, but it also has this really nice capability of MQTT over WebSockets. Now, the MQTT portion is almost immaterial from the perspective of most applications. If you're doing IoT stuff and embedded, then it's meaningful because you can do raw MQTT too. But the fact that you can connect a WebSocket to it means that you can effectively start using pushes back to web browsers, because they can just open a WebSocket and then subscribe to a particular topic, and now anytime you send a message to that topic, it's going out to every user, which is really powerful. However, I do say consider polling, and the reason for that is that the IoT is fairly expensive. Depending on how often you really need these messages, if you need it like in real time, okay, yeah, that's probably your best bet if you're wanting to go serverless. This actually becomes a really good contender as well for hybrid, where you're running servers just as like a WebSocket endpoint or something like that. Just because you can, if you depending on your actual specifics, you may find that that's going to be cheaper, easier to deal with, whatever. So we're building our REST APIs with some background processing. We're alerting people accordingly. What about access control? Which brings me to, in AWS IAM, Identity and Access Management. They're kind of in the lead with this. It's really, really cool. So identity and access management, you can kind of hear two different things. There's identity, there's access management, or authorization and authentication, right? There's a service called Cognito. It allows you to have someone log in as a Facebook user, or an Amazon.com user, or a Google user, or just to have a generic user sign-up flow so they can sign up into a particular, like, okay, this user has signed up in a bucket, right? This is this bucket of users. You can also, if you have an existing authentication system, use Lambdas, call the API gateway with like username, password, and call out to whatever service you currently are using. Validate this is that user, they gave me the correct credentials, and then call into Cognito as well. And either way, you get back a token. I'll get more into that. But once you have that, you can then, authorization applies through policies. Every user can then go and get a set of access credentials that relate to a set of roles, which have a set of policies. And it just, it's this Boolean list of allowed these things, denied these things, right? If you're in AWS at all, you need to understand the authorization process. You need to understand IAM policies. The process is a little different depending on how you're logging someone in. This is the kind of thing that's like, I don't want to dig too deeply into just because it's a little more developer-centric. I kind of sit on the cusp between architect, who's going out and figuring out solutions to these problems, and developer, because some of the times I have to like provide the solution to developers saying, go use this. But yeah, there's two different types of buckets. One's a federated ID bucket. One's just a Cognito bucket, a Cognito pool or user pool. But the federated bucket allows you to sign in someone from saying, oh, they were authorized from this, and it will check that, and then that's what applies a policy. So you create a bucket, a federated ID bucket, saying, okay, here's the roles I want this person to have. And I want people to be able to log into it via Google, via Facebook, via this Cognito bucket, user bucket, whatever. You log into that service. There's APIs for it. And you get an OpenID token. And you just, Cognito has this getCredentialsForLdentity where you say, here's this token from Amazon. And it'll go, yep, that's a valid token from Amazon. Here's some credentials for you. Don't worry, I have some lovely diagrams later, too, because I'm speaking to architects. Generic user pool, create a user pool along with an app ID or multiple app IDs if you're having multiple applications, log into it just as a way to kind of keep track of it. Create a federated ID bucket, same steps, basically. You log the user in via Cognito has authenticateUser. You get back a JWT. You can use that directly in most of the SDKs. Otherwise, you can just call getCredentialsForIdentity with it. And if you're using your own custom solution, create an endpoint that validates user credentials. And then on the back end, if it validates, you create a token for them with getOpenID token for developer identity, and you return that to them. And then on the client, you call getCredentialsForIdentity with that token and that login provider. So we've used all of these except for the Amazon.com, Facebook, Google. Like we've set up user buckets and we have our own authentication flow for different applications. There's a lot of repurposing of some of these services and how they can fit together. It's kind of an interesting rabbit hole. Regardless, the goal is to get temporary AWS credentials. So I promised some diagrams. This is sort of the what I would consider the default. However you get your this is for specifically like I have my own authentication provider, right? I call Amazon API Gateway with like here's my credentials. Here's my password. Here's my username, whatever. Your Lambda does whatever it needs to do to validate that person, right? If you're storing credentials in your own database, you call out to that database. Then once you say, this user is who they say they are, call getOpenldTokenFor for Developeridentity, which is a Cognito-based call. You'll get back an OpenID token. You return that to the client, and then they just call it getCredentialsForIdentity. As a quick aside, STS is built in under this. It's their simple token service. It's not simple. But there's variants of assume role, which allows you to basically call to get credentials from another account. Like you get to specify exactly what role you're trying to assume, and that role can be in a different account than where you got the token. That role has to say, I trust wherever you got that token from. But that allows kind of a cool thing where you can have an identity pool or a federated identity pool and your roles spread out through different accounts, which means you can separate out authentication from authorization, which is really nice because I don't know how you're set up, but for us, we have, a few people should have control of the authentication flow. This should not be something application developers have any say in, have any control in, know any of the secrets necessary for it to work, etc. It should be they get a URL, they pass credentials, they get back a token. But what they should have is their own separate AWS account where they're putting their application in. And that AWS account should have a role that they want users to have. And from that, they can now assume that role with a token pulled from the general account. So it allows you kind of a separation like this, where in one account, I have my application, and I have my role, and it has a trusted principal saying, I trust this bucket in somebody else's account, in the architect's account, right? And the client will call the architect's account to get an OpenID token, and then they'll call the application account to say, give me credentials. And those credentials will apply to the application account in whatever way the application developers have set it up. So that has been really, really useful for us. The point is, either way, however you do it, you get back a set of temporary AWS credentials. And these give you access to every AWS resource. As indicated, they sign, under the covers, everything gets signed. But the AWS SDK will handle this for almost all of your services. A key one that it doesn't is the API gateway. Because the API gateway you can structure in all sorts of ways. You can say, oh, this header is required, this header is not required. Oh, it needs to look like this, not like that. Oh, it should be, basically you have to sign the whole request. And they can't tell you what your request should look like because they can't tell you what your header should look like. For that, you're going to have to sign it yourself if you choose to use AWS's provided authentication. Use a library. It's complicated, but use a library. Allocate a little time for this. All of our teams have taken a little while to get this up and running, especially when we're using like CloudFront in front of our APIs, and then we have a custom domain, and because one of the things you have to sign is the host. It will take a little time. But if you do this, a really nice thing that falls out of it is not only can you start giving credentials to limit what APIs a user can call, and further grained than that, you can say they should only have access to APIs of like user / their Cognito identifier. So you can actually limit it so that they can only get their user profile with a single line in your policy and things like that. It's really, really powerful. But the thing is that it means that unless they have access, that API can't be called, and you won't be charged for the call. So someone can't be spamming an endpoint that you have not granted access to. Which if you're using a custom authorizer and such, you can't do. Like, it's still going to charge you. To that end, there's not really a good way to rate limit users. There's a web application firewall that they're working on, that they're going to be trying to add this. I even mentioned it. It currently sits in CloudFront. It currently sits in the API gateway. You can restrict by IP. But it's a restriction, not a limit. You can't say restrict this IP to only be able to call 3 times an hour. It is instead, this IP can't call at all, or this IP is allowed. They also have something called AWS Shield. It's fairly new. It's their attempt to build something to prevent DDoS. Every account has it. There's an advanced plan that costs like $3,000, no, like $3,000 or $5,000 per month, per year, something pretty heavy. You probably don't need it. I've also asked that they apply this or look to apply this to the IoT, because I would love it if we could like rate limit IoT messages coming in through WebSockets, but we'll see if that gets in. So most of their services, and this is true across cloud providers, are have some sort of access limit baked in. You may need to request these to be raised. Some you can do yourself, and that's what I was talking about, like with Dynamo. You can have code that will see your usage and up it or lower it. For the ones that you can modify, as I said, like tie it to your alarms. It's stuff like if a get state of alarm or describe alarm if state is equal to alarm if it fired. You need monitoring because some of these things you can't control, so you need to know how much you're actually accessing. And again, this ties into like real applications. How do we monitor them? So let's talk briefly about that. They change. Monitoring and alerting changes in a serverless environment. As I said, logs go into Cloudwatch, but they're not that followable because each container logs itself. So they're not, you don't just get this listing of everything that happened in time according to the time it occurred, which is what you're used to if you're using a distributed system anyway, because some requests are going to instance A and some requests are going to instance B, and their clocks aren't perfectly in sync. They have decent searching and filtering such, though. They also have some default metrics that are really, really nice that you can set up alarms for. And then, oh, hey, we're seeing that this spiked, email us, or execute code, or whatever you want to do. But the point is that your focus begins to be on how I set up my cloud to respond to these things, rather than designing upfront how my application should respond. And that's kind of fun. You can configure custom metrics in Cloudwatch. Don't do it. There's an invisible limit to those, and if you exceed it, then you just stop getting metrics, and that kind of sucks. There's tools. Use them. You can, as I said, metrics and events and things can go into an S3 bucket. You can point. There's loads of Cloud-aware tools to point to those. So I mentioned, asynchronous retry, and then you can set them up to go to dead letter queues. And I really want to highlight that, because if something fails 3 times, you need to know about it. You already know that. Like, this is something I care about. Why is it failing so much? So you can do it to an SNS topic, which is your general pub sub, and you can email from there. Or an SQS queue. You can actually bounce through an SNS topic to an SQS queue if you want. Either way, you set it up as part of the Lambda. Over in configuration in advance, there's this DLQ, dead letter queue resource. Just set, you can set up SNS topic or an SQS queue and just set it there. As I said, drop your CloudWatch logs into S3, and you can then process them elsewhere, or point a tool to it. Build an app, monitor it. But as you've been hearing, and as you know, there's more to it than just the development aspect of it. There's also DevOps. Let's start with the code. There's a bunch of libraries for handling code. I really like Serverless. I'm going to talk about it a bit more because it does more than just code. Haven't really played with the others. I've glanced at them. Apex is almost entirely focused on the Lambdas. That's its wheelhouse. Sparta attempts to be sort of a API gateway and Lambda solution for Go. Zappa attempts to be both for Python. And Chalice is AWS's official solution in this space that is, of course, behind everybody else. Yeah, there's some others.
Yeah, there's .NET Framework support, too.
Oh, cool. Great. So he was indicating that there's, OK, you caught it on mic. So I want to go back to Serverless. This is what we use. They've, as you can probably guess from the name, like they got into this space first because they camped on the name. They include CloudFormations as part of your configuration, which is really, really awesome because I can start defining my infrastructure along with my code. So if I'm building whatever, a proof of concept, or if I'm actually building a solution, I can just say, okay, I'm going to need an S3 bucket, call it this. And I can reference that in my configuration that's actually going into the code that's going to be deployed into my Lambdas. So I can define for my dev environment, I want an S3 bucket called this, and my code and my CloudFormations all know that. And because it built it as a CloudFormation, which is immutable infrastructure, it'll only deploy as needed, only add things as needed. It's really powerful because it's one place that describes everything you need in your cloud to be able to run your API with all the backend infrastructure to support the whole application. Because these are new, there's not a lot of tooling around it, but they are all command line interfaces. Like they're all built to be run for the command line, so we've popped them into Jenkins. Just to get it out there, we do have an EC2 instance for our application. It's our Jenkins instance. We've not figured out we have not found or decided to build a good serverless solution for the deployment aspect, because there's kind of a interesting cart before the horse problem there. So as I said, serverless includes CloudFormations. I can't really speak to the others because once we saw that, we're like, yep. We've actually been using it since about like version 0.5 point something, where it didn't have CloudFormations. But if you're maintaining config as config files, because there's other options, throw them into an S3 bucket. Developers know, architects know, DevOps knows, ideally, that your config should be kept separate from your code. Just throw them into an S3 bucket, then they're encrypted, and you can access them with just a role, basically saying my role should have access to this S3 bucket. But if you want, you can actually declare environment variables for Lambdas. I call out serverless here because it's like, oh, that's nice, they do support this. But with that, if you're doing it through the UI, you can basically encrypt them. And then you say, you pick a key, choose encrypt. Problem with doing it this way is that in your code, you're going to have to decrypt them, because what's being stored as the environment variable is the encrypted payload. So you will have to actually make a call out to the Amazon's KMS service to decrypt them. The better approach is just specify, and as you see, this is in configuration. In the advanced thing, set a key. You can even leave it as a default key, which it may even use by default, in which case it'll be Amazon's master key, which they're going to keep pretty tight control over. But that way it's encrypted, and your code just does not have to do anything special. It'll be delivered to your code, to the machines, the underlying VMs your Lambdas are running on, unencrypted. You may have like regulatory compliance or something, so that you have to have control of how long these things persist in memory, in which case this would not be an option, but if you can use it, use it. To maintain, so I heartily recommend keeping dev, stage, prod, whatever environments you have, as separate AWS accounts. Don't try to throw them all into one. You will confuse yourself. It'll make things really unpleasant. And I also really recommend separate accounts for different applications. And this is, again, regardless of whether you're doing AWS, simply because you have too many concerns with fine-tuning permissions otherwise. It's really easy to say this person should have access to dev. This person should have access to dev and prod. It's much easier to do that as this sort of canonical high level, just like, do they even have credentials, rather than trying to scope permissions. There's this thing called AWS config, and it tracks what changes you make. This can be really useful to know what the heck a dev did to make it work. Because sometimes if they're just playing, they might not be writing CloudFormations. They might just be writing it, like spinning stuff up by hand. Honestly, I've done that too. Like, I just want to see if this will even work, so just do it. And then be like, okay, now I need a CloudFormation. Well, what did I do? So this ties into testing. When you're going with serverless, because the cost, and I'll touch on this a little more toward the end, but the cost is effectively zero if your usage is zero. there's some caveats there. If you have Dynamo and you've upped your throughput really high, you're going to be paying for the throughput. But if you're using S3, if you're using Cognito, you're using Lambdas in the API gateway, you've set all this stuff up and you're not using it, you're not paying anything. So there's no problem with building an actual copy of production as my dev environment. It's what we've all been told to do, but frequently just the amount of effort involved. Oh, I've got to have, I better go learn everything about Docker and Kubernetes so that I can make sure that my configs are following me properly and that I'm not accidentally leaving something unchanged between dev and prod. There's complexity. Here it's actually really easy. So do it. Just have your own separate account and be like, okay, this is a copy of prod. You want to load test it with production-like levels? All right, load test it with production-like levels. Like, you can just do that. You don't have to spin up new infrastructure or do anything. This is exactly what is checked into prod or deployed in prod. So target that. When you write your integration tests, do that. Again, per the keynote, a lot of server-based things you end up having to isolate. Like, I'm going to test this small little microservice in isolation and mock out where it's touching my other things because it's just too complex. Here, just test the whole damn thing. Heck, spin up a new AWS environment just to go throw everything in so devs aren't even touching it. Every dev can have their own account to go play with the entire system if you want. Like, it's that easy. Just kind of grab bag of odds and ends. Latency can be a problem, but not always. So I mentioned that when it's just cold starting a container, and again, this applies across all of the cloud providers, it can take a little time, more than just the actual execution. Once it's been pre-warmed, my function can take milliseconds, but prior to that, it could take a couple seconds. And in a VPC, it can get really bad just because it has to actually spin one up in your environment and allocate a ENI to it and that sort of thing. And a lot of people get turned off by this, but it turns out this doesn't matter that much for a lot of applications. The reason being, if you bank on your mobile phone or really do anything, and you go to sign in, you see that pinwheel, and you wait for it. Because you're just used to, oh, right, 4G networks, yeah, they're super fast, yeah, but it's a bank software, or it's whatever. Like, we're used to waiting for action. We're not used to waiting for websites. But all the research you've seen about, users will go, 50%, you'll lose 50% of your users if your website does not load up in X milliseconds. Well, that was your images. That was your HTML, your CSS, your, the visual thing. Yeah, I'm not saying serve that stuff up from your APIs. That would be terrible. That's what S3 and CloudFront are for. But your functionality, my login, that can take a while because users are already trained to wait for that little pinwheel to finish. So it's worth testing. It's worth thinking about and reevaluating what does user experience really mean when it comes to latency. That said, you can have functions that are firing to go and call these lambdas with little payloads that are specially recognized as do nothing just to keep some containers in place. I don't really recommend it just because it's not really predictable. It will reduce the number of people hitting those cold starts, but not eliminate them. But you can do it if you want to just like make it so you're, the even more of your users are getting a decent experience. Use CloudFront for caching. It's got some things like I don't think they've enabled AWS Shield for the API gateway yet. They might have, but if so, it was within the last couple weeks. It's an extra layer of indirection, obviously, which does make things nice because you can have like, okay, this one URL endpoint, even without touching DNS, is going to sit in front of this and in front of this and route requests with this path over here and that sort of thing, which is, we all love indirection. It's got better TLS options. It allows for you to basically specify what versions of TLS you want to support. It also, as we learned recently, supports IP version 6 when the API gateway does not currently. So if you have a mobile application you want to get by Apple, you're going to have to go through CloudFront. But that said, don't cache error codes. We've been bitten by this. By default, it will. It'll say, oh, you returned to 500. OK, we're going to keep that for the next hour. It's easy to fix it. Just create a custom error response for the error code. Say 0 as your time to live. The API gateway does have a checkbox for cache. It's not worth it. That's maybe if the pricing model is more attractive, but it's a different pricing model than CloudFront and doesn't give you any of the benefits that I just mentioned. All it does is cache. As you start seeing a lot of use, you may want to rethink your API design. And the reason for this is when we're all hosting everything on our own, it makes sense to be like, okay, I want to get nouns of type A, and so that's one call, and nouns of type B, and that's another call. And so our client will make both of those calls. But in a serverless environment, both those calls cost us money. If we call it once and then have it, once it's inside the Lambda, asynchronously go and request both types of nouns and return it, well, we paid for one call instead of two. At scale, that might matter. When you're in a proof of concepting, it doesn't matter, but just something to think about. Route 53 is their DNS service. I've not gotten to play with the other cloud providers and see if they have one. AWS does, and it's awesome. And the certificate manager gives you certificates for free, which is quite nice because even if you're using a domain hosted somewhere else, you can use that. It can run in your load balancers if you're using standard EC2 stuff, but it'll also work in CloudFront. It'll also work in the API gateway. So this way you can have SSL encryption for custom domains for free. And the nice thing is it's fully managed, so it will automatically renew the certificates for you. You don't have to do anything. You don't have to go swap them out or anything else. It all automatically happens unless you choose to cancel it. So you just know forevermore this domain will work and you can walk away. If serverless sounds like something useful, the first step is probably sticking the API gateway in front of your existing solution. Because it allows just to do an HTTP pass-through where it'll just send everything that got into it directly to your application and then return the response. And that allows you to piecemeal go in and start re-implementing them as Lambdas. If you already have a good story for how we're deploying and everything else and you're happy with it, there's no reason to do that. And I'll touch on that as just a brief summary at the end, but it's something to think about. Write Lambdas as libraries and isolate the handler code. If ever you want to move away from serverless, you're going to want the code that's actually doing all the work separate from the code that's integrating with the API gateway. It's easier than it sounds like. This is just a quick little example where I've got just to check to see if I sent a specially crafted event if I wanted to use a pre-warming thing, or I just send a body that says, is pre-warm equals true? Well, JSON, but otherwise it's just calling out to a library I wrote. So just write everything as a library that gets pulled into the super lightweight function whose sole result is to transform the event in context into something that goes in and transfer any response back out before the callback gets called. You can unit test your code this way really super easily because it's just a library. You know how to unit test those. As I said before, integration test against the environment. It's super easy there too. So I want to just, that's kind of the technical side of things. I want to just get sort of broader and just why you might consider doing this or, why you never would. So costs are more visible. Like, as I said, if you're not using anything, even with everything deployed, but your user count is like, there's nobody using it, you're not paying anything. And it's fairly predictable. Oh, we're going to have 1 million calls. All right, well, that's going to be, we set our Lambdas at this, so that's going to be like 50 cents, $1 per million calls. And oh, our API gateway, $3.50 per million calls. Okay, so it's going to be $4 per million calls. And all right, we're hitting Dynamo. All right, what's our throughput set to? All right, if our throughbut continues at this, it's going to be, you can actually construct your costs pretty easily this way. Whereas if you're using EC2 instances, if they're constantly in flux to support load, that's harder to do. And that's a benefit. Complexity is hidden. Well, as I said, a lot of that's being thrown onto Amazon. We've abstracted more and more things to sort of our core, the core of what we care about, the code. The actual what is this thing doing, and the rest of it, the how is that code being spun up, how is that code being scaled out, that's thrown on Amazon. It's stateless. For distributed systems, you want stateless. By that I mean it's stateless in the code. You don't want things stored in memory. You don't want to have to be locking things or otherwise distributing that state out. Because of that, it scales trivially. That's great. We love knowing that this thing that I spun up into an environment, it took me like an hour to write and I'm done, can scale infinitely. That's awesome. And it's secure if we trust Amazon. Like I don't have to deal with it. They have a very clear guideline for what to do. There are, of course, cons. You'll note the first two are the same as the pros. Costs are more visible. How much does your DevOps cost you? I don't know. I don't think any of us know. We can say, oh, well, we have X number of DevOps people and the average salary is this and that. Are they the only ones doing DevOps? Are your software people doing DevOps? Who's doing sysops? Who's being concerned about, hey, this OpenSSL has another vulnerability. Who's patching that? Like, these are costs that are very hard to quantify, and because of that, they're hidden. And that's makes it, in some cases, seem like a traditional solution built on VMs is going to be cheaper, when the reality is who knows? It might very well be, but it's hard to prove that. Complexity is hidden. Sometimes things go wrong, and you don't know why. You have to engineer for being fault tolerant. You have to engineer for, okay, it needs to be across region, hopefully, and you still have many of the same problems of any distributed system. But now you also cannot penetrate down below, okay, here's what's deployed as these lambdas. You can't go and see what's the state of this server. Because it's stateless, if you have developers who haven't been doing a lot of distributed stuff, they aren't going to know what to do. Like, how do I deal with not being able to persist state around or having to call it to a database? And it just creates an extra level of thought that has to go into it. Cold start could be an issue. That's the reality. And this is pretty new. The tooling's pretty immature. It works. We've delivered production systems with it, but it's still very young. And obviously, I've been talking to a lot of Amazon because there's some vendor lock-in. Once you start taking advantage of the services, you start saying, all right, well, how can I use these other services? Or how can I have this problem? How do I solve it in this context? Because going to another cloud provider is going to, at minimum, cost me data transfer costs. And there's this just larger hill to climb, this larger obstacle I have to overcome to make it worthwhile. So real quickly to just kind of go over this, this has worked really well for us. We've got I work for a digital accelerator where we're doing a lot of just like trying things out. And we can get basically something up and running, very, very quickly this way that will scale pretty much infinitely with minimal effort on us, if any. That's really cool. And the costs start out really low and only as it scales. We also don't have the DevOps people. Like, we just don't. We don't have the experience for doing proper blue-green deployments with full-on Docker and Kubernetes. If you have that and you're doing it right, it may not be a compelling thing to switch to serverless. It's just, I know for a lot of people they're not doing it right. It's one of those where, as an architect, it's kind of your job to figure out, will this fit our use case? Speaking of, if your application has really low latency needs, this will not fit your use case because, as I said, there is some built-in latency there. Similarly, if your application fundamentally is state manipulation, lots and lots of just complexity around that state, it may be harder to do in this. I'm not going to say it's impossible because people still do stuff like that even in like Haskell, right? Where it's pure and immutable and etc. But it may be harder. But I would encourage you to definitely consider this for especially any greenfield development you're doing. I also, if it sounds interesting, say go have a look at David Akhteri's talk. He's actually going to walk through building, as he said this morning, a full demo of full stack demo. Here's a client calling into my gateway and lambdas that are actually executing code and doing things, just to kind of really consolidate some of this stuff in your head. I will actually be out on my way to take a plane, but I'm actually very interested to see how he demos it, because I was originally going to include a demo in this, and I was like, nope, I'm going more breadth because someone else is doing a demo. So I just want to go ahead and ask, are there any questions or comments, or just screw yous and angrily storming out of the room?
Yeah, thanks for this. It was really good. I just had a quick question. I'm trying to work through my head. In your opinion, what are the use cases you see for this serverless architecture?
Sure. So what we've done, so basically any sort of typical business CRUD-like thing, this is an amazingly good candidate for. Where your source of truth is fundamentally going to be some back-end database or data store. But what we've done, just to give you some actual examples, we have a couple mobile apps which are using serverless backends. Now, they're already frameworks out there for serverless backends. But this allowed us to, we're using the IoT platform to stream data in and then send back data so that one person could be collecting data, one can view it. Or for IoT usages, for user management, we're calling in through the API gateway. I was talking about authorization. That's what we've done. We have sort of an authentication scheme that we inherited from IT because it's what the brand websites are all using. And we have products that have to integrate with the brand websites. And so once I figured out how to integrate with that, I built an authentication service that's sitting in its own AWS environment where, all the apps can go to that to get their token, and then they go to their environment to actually get the temporary AWS credentials that represent the role and permissions they have, and then they use those to access other AWS resources. We have like file uploads where we can just go straight to S3 rather than having to bounce through something, which a lot of people were doing anyway. But because of that, we only have one set of credentials, the AWS credentials, rather than having one to talk to our own applications and to go directly to AWS. And it's really nice knowing that, basically the only thing we have to do to make this scale, because a lot of these, since they are user-facing apps, we have no idea what the scaling needs will be. If we just have, one request every 10 minutes, it works fine, and we charge very little. And if it jumps up to 10,000 requests per second, it'll work fine. The only thing we really have to do is up the concurrency limit on our Lambdas.
So to that same extent, I'm trying to picture now. So I have whatever small applications I have that I'm making, and I'm having a hard time figuring out. So you just said a couple use cases. Mm-hmm. Would it seem that you'd first start with Dockerizing and making things into their own services, and then once you have that, looking at which parts can be kind of spun off as, all right, this is independent and doesn't touch the state or such like that. How would you view that progression?
So, the way we've done it, at least, the way I would normally think of it is I would actually start with, the same way we do with applications, break it up into functionalities. And then for each functionality, kind of focus on, is this something that I can envision in some serverless manner? What part of it does not fit serverless, right? What part of it can I not imagine not having state around? And then go investigate the AWS docs, go look around, see is there something that'll do that, or that I can leverage into doing that. If there's not, it's a perfect excuse to do a hybrid. Like throw that into an AC2, fine. But if you see that, a little fiddling, I can fit it into this, does it make sense to? That's the next question, of course. Like, I can do it. Should I? At that point, start saying, well, would this kind of make sense? Do I gain some benefits from it? Because there are some innate benefits in that it is very quick to get up, to scale across. So you don't have any of the Docker and, all of the containerization, is not a problem there because you're not using it. You're leaving Amazon to deal with that. But if there's that benefit there, then say, okay, I'm going to deal with this one. If you're starting greenfield, I would actually start with even thinking about your APIs and saying, all right, per API functionality, I can't have stuff sitting in my application because how is that going to scale? It has to be across multiple sets of that application at minimum, but at that point, why am I not trying to find some hosted service to store it into? Why am I taking the distributed nature of this data or the state manipulation upon myself? Are my developers great distributed system developers? If so, maybe it makes sense. Maybe there's a value for it. But if that's not what they're great at, why am I not looking for some external service? And then once I push the data in there, well, then what's left? Well, something I can deal with serverless. And just, it may take a little work and just kind of viewing it from a number of different angles. But fundamentally, what I would say is start kind of looking at the APIs too, to figure out what obviously could be serverless. Oh, this is just going to get something from a database. Pfft, obviously, that can be serverless, that sort of thing. And just thinking along those lines. What I will also comment is, this is very new. There are no best practices yet. There are reasonable practices. There are some terrible practices and anti-patterns, but there's no best practices yet because we're still figuring it out. So it becomes one of I can give you some guidelines I've used, but fundamentally you're gonna have to look at your problem and say, does this fit? And I mean, that's true of everyone here, that for any kind of, not just this, but any kind of problem. It's just, unfortunately, I don't have here's a lovely, flow chart to work through this until you get an answer. So, anyone else?
So along those same lines, what type of granularity do you use when you build these in terms of, how long running? Is it a small thing? How many of them are there? And is it complicated to manage at all?
Okay. So long running, I'm not sure is like really applicable, just because in terms of or do you just mean the lifespan of the application?
Like, is it one Lambda per request? Do you bundle them together to do a big job?
It's going to be one Lambda per request. The API gateway maps one request into one Lambda. So then we have to figure out, for user functionality, how does that map into a request? As I said, I frequently start with like, okay, I'm going to try to make a pure REST, again, whatever that means, interface. But then I start saying, all right, based on what my, the user side is doing, like based on the client app, it's actually every time it makes a request to this endpoint, it's also requesting this one, because it's always showing this data together. Why don't I combine them? Because it's going to be less cost, that sort of thing. So it starts out as like any other REST API, but it begins to kind of pare itself down into how am I actually using it. And I'm trying to train myself to first go and say like, all right, what is the front end going to look like? And then I'll start kind of designing the back end, which is kind of backwards to how we're used to doing it. But by doing that, I can frequently cut costs down by as much as 50%, because I can, in terms of I'm sorry, I'm
management of all the different
okay.
Lambdas.
So frequently, what we have it set up so that different applications are kind of in charge of their own thing, and then as I'm not even officially an architect. I'm doing architectural duties, and we don't have architects yet. We're working on building an architecture team.
Looks like they do.
Yeah, well, yeah, I'm the de facto. But as part of that, I'm kind of spread across the teams looking for shared functionalities. And but frequently, it'll be like they'll kind of sit down and hammer out, like, what do we think our API should look like? And then they'll come to me, I'll say, that looks good. Or why don't you break it up this way because reasons? But happily, it's not that important if it's split up based on this team is in control of this chunk, and that's the granularity you have. It doesn't really matter how large that is, because they can fit it into one like serverless project or whatever, and which is, again, I heartily recommend using a framework, because then it's a nice isolation, like separate handlers per function, and then there's one configuration file which says, okay, this endpoint maps to this function. But that's a very easy thing to merge. The code can be kind of nicely separated out. It's no different than working on any other application in terms of like you're working on this library that every handler calls into. So yeah, and they can split it out if they want to. And sometimes it makes sense just because if they recognize this module is going to be deployed a lot more than this one, or might be deployed separately because it's handling something innately different for their application, then they may separate it out into two serverless projects, which will become two different APIs. But that's effectively the level of granularity that you are looking at, is level of APIs. One caveat with that is that if two APIs are talking to the same database, only one of them should have the CloudFormation. Because otherwise, with two CloudFormations, there'll be separate ones, and they'll both say create a bucket named this, and they're going to conflict. Or both say create a table named this, or whatever, and that will lead to conflict. So you'll need one of them to decide, I am the owner of this resource, and so I will be the one deploying it. And so you may, but again, that's why I say focus on ideally, you have one team per application, and so that they can manage that communication within themselves rather than having cross-team communication, which is just a whole nother level of complexity.
Thanks.
Any more questions? Oh, there in the back.
If you have a Lambda that's shared across multiple applications, do you deploy that each with its own application, or do you deploy it separately underneath something else?
It's largely up to you. You can make it so that each application's so fundamentally you've got a Lambda, you've got an API that may or whatever's triggering it, right? Maybe it's the API gateway, maybe it's something else. You can reuse that Lambda, but obviously there's some concerns about that. It's the same thing as like any sort of shared function in a code base, right? Should I rely on this function that's being relied on elsewhere, or should it be separate? I don't have an answer for that, just because it's the same problem. If I share it, then any fixes I will benefit from, right? Any updates to that Lambda that fix a problem, I will benefit. But any major changes in its functionality will break me. So it's that same problem. So I would say it's case by case. You have to decide that. Does it make sense to make a copy of the Lambda and spin up store a new one, or rely on the same thing? And the storage costs are so minuscule, it doesn't matter. So it's entirely up to you as to whether or not it's a new function or not, based entirely on whether it makes sense for there to be this dependency or not.
One more.
How long does it take to start up? basically the Lambda. I mean, you deployed it and you're ready to process the first request. So how long does it take to create the instance? In your experience,
Sure.
average time.
So the cold start, if it's not in a VPC, 1 to 2 seconds maybe for that first call. If it is in a VPC, I've seen as high as like 4, which is another reason I really would caution you against using RDS. But at the same time, like if your use case fits it, why not? But yeah, there can be a little startup latency there that's measurable. I would say profile, as you know, as with any performance measure, profile. But it's within the order of between 1 to 3 seconds generally.
I think it's time to thank Christopher for his talk today.